Welcome to The Explainer. Today, we are taking the absolute fire hose of recent AI releases and filtering it down into a highly structured spec sheet specifically for you, the developers. We're going to map out the newest open source tools to hit the repositories this week. We'll be starting from incredibly lightweight local models that you can run on your phone right now and tracing the technology all the way up to full, automated agentic pipelines. If you want to know what to build with, what hardware you actually need to run it, and where the easiest entry points are, you are absolutely in the right place.
Okay, let's dive into this. We are categorizing these open source tools from the most accessible hardware requirements right up to the most advanced integrations. So we've got 1. Beginner local models. 2. Audio and video generation. 3. 3D assets and robotics. 4. Interactive world models. And 5. Agentic media pipelines. Let's get started.
Section 1. Beginner local models. This is really the beginner's starting line for developers looking to tinker without needing a server farm.
So if you're a developer who wants to start tinkering with vision and language models, but you don't happen to have a massive, expensive server farm sitting in your garage, Mini CPM v4.6 is exactly where you want to begin. This is a tiny, highly efficient vision language model. And what makes it so incredibly useful is its capability to perform general reasoning, analyze documents and charts, and even understand graphical user interfaces directly on edge devices. Think of this as a local visual assistant that lives entirely on your phone. It works smoothly across iOS, Android, and Harmony OS, and it's capable of processing inputs directly from your camera stream while maintaining an incredibly high intelligence index relative to its small token usage. It's really cool.
Now, what's really interesting about this slide is the incredibly low barrier to entry here. Look at those total storage sizes. Mini CPM is just 2.6 gigabytes for the entire package. And right beside it, we've got a new tool called Just Dub It, which translates and adjusts lip sync on videos. It's built on the leading open source video model, LTX 2.3, and it actually outperforms major commercial competitors like HeyGen for video dubbing. The open source code is right there on GitHub, and the whole package weighs in at only 2.5 gigabytes. That means you can easily run this locally on a lower-end GPU to test it out.
Moving on to Section 2, Audio and Video Generation. We are shifting into the heavy-duty media generators now.
All right, so we are moving up the hardware ladder. Your local hardware demands are definitely going to increase here, but as a trade-off, your creative and programmatic control just skyrockets. Take a listen to this. He stares at the lottery ticket, hands shaking, voice rising from stunned disbelief to uncontrollable excitement. Now that isn't from a movie script. That is the exact stage direction syntax used to prompt the new highly expressive text-to-speech tools released this week. Tools like Cinema Audio and Resemble AI's Drama Box let you script the exact emotion, accent, and breathing patterns of the generated voice. And what's super fascinating from a developer perspective is that both of these incredible audio tools were cleverly extracted straight out of that same open source video model we just talked about, LTX 2.3. The video model's understanding of audio was so inherently good, they literally just pulled it out to use on its own.
But I have to give a strict hardware warning here for developers. To run these expressive text-to-speech suites locally, which for a tool like DramaBox means loading an 8GB Gemma text encoder right alongside the audio models, you're going to need a CUDA GPU with a peak of around 24GB of VRAM. This 24GB threshold is also the exact requirement for other new video tools we saw this week, like Relight Live, which actually lets you programmatically change the harshness, shadows, and angle of lighting on an existing video locally. So if you want to play in this space, 24 gigs is pretty much your new baseline.
This category also brings a massive architectural shift in how these image models are designed, moving from latent space to pixel space. Here's the deal. Traditionally, models generate images in a compressed, latent space to save compute, and then they use a VAE, a variational autoencoder, to turn that back into visible pixels. The problem? That process often makes the output look a bit plastic or thick. But these newly released asymmetric flow models completely bypass the VAE. They generate directly in pixel space, resulting in hyper-realistic fidelity and incredibly sharp textures. And thanks to some clever architecture tweaks, they've actually made this pixel space generation 40% faster. It goes to show that local compute is no longer the bottleneck for achieving this level of realism.
And here's the best part for developers. Hitting the code button on their GitHub repository gives you so much more than just basic inference code. You are getting the complete package. Base model weights, the actual training code, evaluation scripts, and detailed local download instructions are all right there. They aren't holding anything back, which makes this highly extensible for your own local fine-tuning and testing.
Section 3, 3D assets and robotics. We're officially entering the spatial domain.
As incredibly advanced humanoid hardware arrives on the market, like the newly announced 23 degree of freedom Zinova Flex 2 robotic hand that can actually dynamically detect slip and tighten its grip, developers desperately need better, more accurate 3D training assets to simulate those physical environments. Enter Pixel 3D. This is a high-fidelity image-to-3D generator, and it completely crushes competitors by explicitly connecting the 2D pixels in an image with the 3D structure for incredibly accurate geometry. Instead of loosely giving the AI an image and just crossing your fingers that it understands which pixels belong where in space, it uses pixel-lined mapping to ensure all those details make it to the final mesh. It is available for local installation right now, but just remember that 24GB rule from earlier. You're going to need the space to run it.
And this brilliantly illustrates our next tool. What if you need those 3D assets to actually move? Well, Artecraft takes a totally new approach by turning 3D asset generation into a literal coding problem. So instead of forcing an AI to directly imagine a final 3D mesh in one shot, it asks an AI coding agent, like GPT 5.5, to write a program that defines the geometry, the parts, the joints, and the hinges. The output you get is a functional 3D mechanic with separate parts and realistic motion, rather than just a frozen, static mesh. So comparing these two, you can see they serve distinctly different developer needs. Pixel 3D is your absolute go-to for static, hyper-detailed 3D meshes, which is perfect for game development or product visualization. Artecraft, on the flip side, is totally agent-agnostic and generates articulated, moving objects. Crucially, developers now have access to Artecraft's massive open-source dataset of 10,000 articulated everyday objects. If you're building robotic training simulations and need to teach a robotic arm how to manipulate objects, having access to this data is a complete game-changer.
Section 4. Interactive World Models. Welcome to fully navigable spaces.
Now we are talking about tools where you can generate a fully realized 3D space based on just a single image prompt, and then actively navigate that space using standard WASD key presses on your keyboard. It's wild. A massive release in this category this week is Sonnet WM from Nvidia. It's a 2.8 billion parameter open-source interactive world model designed to run on a single GPU. They trained this thing using over 200,000 public video clips with camera pose labels, and it only took them 15 days on 64 H100s. To make it even more accessible for us developers, Nvidia created a distilled, quantized variant that is so efficient it can generate a minute-long interactive clip in just 34 seconds on a single RTX 5090.
So, as a developer, you actually have multiple options right now to start testing this tech. While Sonnet WM's code and models are marked as coming soon, you can immediately jump into Warp as History, which currently has its code, models, and fine-tuning scripts available to download right now. Or, alternatively, there's DreamX World, which has a highly efficient 5 billion parameter model available to run locally today. You literally have everything you need to start building interactive environments today.
Let's move to and see how this builds into Section 5, Agentic Media Pipelines. We're entering the automated full-stack era.
This is really the climax of the explainer. We're shifting away from isolated tools and stepping into the realm of fully automated, full-stack creative engines. Let's walk through the Higgs field MCP workflow. In Step 1, an LLM like Claude acts as the brain. In Step 2, Higgs field MCP acts as the hands. Instead of the AI just spitting out a block of text, it uses those hands to natively generate and ship videos, images, and full landing pages end-to-end. And Step 3 is where the magic happens. Everything outputs straight into your local working directory. There's no manual exporting of files, no frantically switching tabs. You prompt your agent, and the media just natively appears right on your machine.
These tools are fundamentally reshaping developer workflows. Higgs field MCP gives your agent the ability to spin up an entire real estate media kit of images and videos automatically, with zero config drift across models. Meanwhile, OpenAI Codex now lets you steer your macOS coding agent remotely from your phone, meaning you could literally trigger your computer to fix a bug while you are physically out getting coffee. And Google DeepMind is literally repurposing the computer mouse cursor. By linking it with Gemini, your cursor becomes a tiny visual context agent that instantly understands whatever PDF, chart, or block of code you happen to be hovering over.
So, the crucial point is this. We are moving incredibly fast from a world where developers had to painstakingly write the code to stitch together individual generation models to a world where AI agents natively handle the entire creation pipeline for us. When every media generation tool is seamlessly orchestrated by an autonomous agent, what will your role as a developer become? It really seems the future is less about coding individual isolated features and much more about orchestrating and directing these massive, highly capable agentic pipelines. What an absolute game changer of a week for AI. Thanks for joining us on this explainer, and we'll catch you next time.